Hey everyone, ready for another deep dive?
Always.
Awesome. So today we're going to be looking at facial recognition systems,
Oh, wow.
or FRS as the cool kids call them.
Right.
That
Okay.
thing that unlocks your phone.
Yeah.
Well, it turns out
Mm-hmm.
it's way more complicated than you might think.
Oh, I bet.
And luckily, some of our awesome listeners sent over some really fascinating documents
Nice.
about all the ins and outs of FRS.
Really interesting stuff.
Yeah, and so we're going to be taking a look at, how they work,
Uh-huh.
the challenges they face, and even how to build your own model.
Wow.
So get ready to have your mind blown.
It's amazing how this tech is everywhere now.
It really is.
But most people don't even know the basics.
Right.
These documents, though, really get into the nitty-gritty.
They do. They really pull back the curtain
Yeah.
and show all the innovation that's happening in the FRS world.
Absolutely.
So let's jump right in.
Sounds good.
The first thing that stood out to me was all the problems that FRS is facing.
Oh.
It seems even this cutting-edge tech isn't perfect.
Well, you're right about that. There's a lot of challenges.
Like what?
Well, the documents mention model latency,
Okay.
pipeline scalability,
Uh-huh.
and even high memory consumption.
Whoa, big words.
Well, they sound complicated, but they're actually pretty simple.
Okay, break them down for me.
So think about when you try to unlock your phone with your face and it takes a couple seconds.
Yeah.
That's model latency. The system is taking time to process everything.
Oh, okay.
Now imagine that delay happening with security cameras in a busy airport.
Oh, yikes.
Not a good situation, right?
Definitely not.
And then you have a problem of handling massive amounts of data.
Right, like in that airport example.
Exactly. Those cameras would need to process thousands of faces at the same time.
That's a lot of faces.
It is, and to make things even harder, these processes take up a ton of computing power.
I see.
It's like trying to run a brand new video game on an old computer.
Things are going to slow down.
Exactly. They call that high memory consumption.
So it's like a balancing act.
Mm-hmm.
You need speed,
Right.
you need to handle a ton of data,
Yeah.
and you need the computing power to make it all happen.
It's like juggling flaming torches.
That's a good one,
Thanks.
but it doesn't stop there.
Nope.
The documents also talk about how even with tools like DeepStream and multi-GPU and even this thing called DGX SuperPod,
Mm-hmm.
there are still limitations.
Yeah. Even with all that amazing tech.
So what kind of limitations are we talking about?
Well, one big one is still limited scalability.
Okay.
Meaning, even with all the fancy tools, these systems can still struggle with huge data sets in real time.
Like what kind of situation?
Imagine like Black Friday online shopping.
Oh, yeah?
But instead of websites crashing,
Huh?
it's your facial recognition system that can't keep up.
Whoa.
Yeah, it would be chaos.
So what's the other big challenge they're facing?
Performance constraints trying to get accuracy and speed at the same time is really tough.
I bet.
It's like asking a chef to make a gourmet meal in 5 minutes.
Not going to happen.
Right.
So it seems like there's a lot to consider even before we dive into the really technical stuff.
Yeah, definitely.
But hey, before we get too deep in the weeds,
Okay.
let's take a step back and define what an FRS even is.
Good idea.
Like at its core.
At its core, it's about identifying and verifying people.
Okay.
So not just recognizing a face,
Right.
but actually knowing who that person is.
So it's like matching a face to a name in a database.
Exactly.
Now, the documents highlight 3 big names in the FRS world.
Oh, yeah.
They mention DeepStream, NVIDIA DGX SuperPod, and how those two can be combined.
Those are some big players.
They are. So first up, what exactly is DeepStream?
Well, think of it like the engine
Right.
that powers a lot of facial recognition systems out there.
Got it.
It's NVIDIA's platform for building video analytics solutions.
And those solutions include FRS.
Yeah, things like that.
So it's like the foundation for building these systems.
You could say that.
And what about this NVIDIA DGX SuperPod?
Now, that one is really interesting.
Okay, tell me more.
So imagine a supercomputer
Wow.
specifically designed to train and run FRS models.
At super speed, I'm guessing.
Yeah, exactly. It's like a gym
Uh-huh.
where these models get buff and learn to recognize faces with incredible accuracy.
So it's the muscle behind the whole operation.
That's a good way to put it.
And when you combine DeepStream and DGX SuperPod, what happens then?
Well, you get a system that's not only super powerful,
Okay.
but also fast and scalable.
So it can handle all those challenges we talked about earlier.
Exactly. It can handle tons of data
Right.
without breaking a sweat.
Nice.
It's a pretty powerful combo.
So we've talked about the problems and some of the tools, but how did these FRS models actually learn to recognize faces?
Well, the documents mention something called face.evolve.
Okay.
And it's kind of like a specialized toolbox
Oh, interesting.
designed just for building and training facial recognition models.
So it's the software that the pros use.
Yeah, you could say that.
And what kind of model are they training with this software?
They're using something called an IRSE50 model.
IRSE50.
Yeah, it might sound complicated,
It does.
but it's basically just 3 proven methods combined together.
What are those 3 methods?
ResNet CSI, SResNet, and Inception ResNet.
Okay, more big words.
I know, but think of it this way.
Okay.
They capture features from all different angles.
Uh-huh.
They then zero in on the most important details.
Like the shape of your eyes or nose.
Yeah, exactly.
And then they use this squeeze and excitation thing to really remember those features.
Exactly. It helps the network understand and remember those features even better.
So it's like giving the model a photographic memory for faces?
Yeah, but with a little extra boost
Right.
to make sure it remembers the important stuff.
Makes sense. So within this IRSE50 model, what are the key parts?
Well, you have the IRSE50 backbone
Okay.
and the focal loss function.
Those sound like superhero names.
I know, right?
Uh-huh.
But they're actually pretty simple.
Break it down for me.
So the backbone is like the foundation. It's responsible for extracting the important information from each face.
I see.
And the focal loss function helps the model learn from its mistakes.
Oh, so it's like a coach.
Yeah, you could say that.
It's pushing the model to be the best it can be.
Exactly.
Now, the documents mention this model is really good at its job,
It is.
especially on benchmarks like LFW and megaphase.
Yeah, those are like tests for these models.
Oh, okay.
And IRSE50 aced them.
Pretty impressive.
But a model is only as good as the data it's trained on, right?
Makes sense. So what did they use for this model?
Well, they used a data set called Kocia WebFace.
And that's important because...
It's huge. Almost 500,000 images of over 10,000 different people.
Whoa, that's a lot of faces.
It is. And they made sure to use the clean version of the data set.
What does that mean?
Well, it means the images are high quality,
Okay.
no blurry selfies or anything like that.
So no bad data, messing things up.
Exactly. And on top of that, it's a very diverse data set.
What does that mean?
It means the pictures have people with all kinds of different lighting expressions and poses.
Oh, I see.
So it's like the model is getting real-world experience.
So it's ready for anything.
Yeah, basically.
Now, how does this massive and diverse data set work with that backbone we talked about?
Well, you can think of the backbone as a master puzzle solver.
Okay.
It's taking all the information from those diverse images and learning how to tell even subtle differences between faces.
Like a facial Sherlock Holmes.
Exactly.
So they trained this model on a massive data set.
Yeah.
But how do we know it actually worked?
Well, they tested it.
Of course.
They used a benchmark called eMore, which has all kinds of different data sets.
Uh-huh.
And the model did great.
Like passed with flying colors.
Exactly. It was really accurate across the board.
Awesome.
Yeah, all thanks to that IRSE50 backbone, the arc face head, and the focal loss function.
Those names again.
I know, right? But they work great together.
Clearly.
And we can't forget about Kocia WebFace.
Right, the data set.
It played a crucial role in getting those great results.
So practice makes perfect, even for AI.
Yeah, you could say that.
But training a model is just the first step, right?
Right.
How do we actually use this technology?
Well, that's where platforms like NVIDIA Metropolis come in.
Oh, yeah, I've heard that name before.
It's basically a one-stop shop for building and launching FRS systems.
Really?
Yeah, everything from gathering data to creating the model and then even deploying it.
So it's like having all the tools you need all in one place.
Exactly. It makes things a lot easier.
I bet.
It also speeds things up and lowers costs.
Nice.
And perhaps most importantly, it's really flexible.
What do you mean?
You can use it for all kinds of different FRS applications.
So it's adaptable.
Exactly.
Pretty cool.
Yeah, it's a really powerful platform.
Now, I remember DeepStream was mentioned a lot in these documents.
Oh, yeah.
Can you remind me what that is again?
It's the core platform for building real-time analytics applications.
And FRS is one of those applications. So it's kind of like the foundation
Uh-huh.
on which all these cool facial recognition features are built.
Exactly.
What makes DeepStream so special?
Well, it's designed for real-time analysis.
Yeah.
So it can process video data as it's coming in.
That's important for like security cameras, right?
Yeah, for anything where every second counts.
I see.
It's also really flexible and scalable.
What does that mean?
Well, it can adapt to different situations,
Uh-huh.
and it can handle more and more work as needed.
So it can grow with the task.
Yeah, exactly.
And it works with lots of different hardware and software.
It does.
So it's powerful, flexible,
Yeah.
and easy to integrate.
It's a pretty impressive platform.
It sounds like it.
It really is.
So DeepStream seems to be like the key to making all this FRS stuff work.
It definitely plays a big role.
But to really understand it, we need to look at the DeepStream SDK,
Right.
which provides the tools to actually build these applications.
Exactly.
So tell me what's in this SDK toolkit.
Well, for starters, you have turnkey apps.
Turnkey apps.
Yeah, they're ready-to-use applications.
Oh, so you don't have to build everything from scratch.
Exactly.
That's nice.
It also has a graph composer, which is a visual tool for building DeepStream pipelines.
Okay.
And it supports a bunch of different programming languages.
Options are always good.
They are.
What else does it have?
Well, it has a container builder to help you package up your applications, and accelerated plugins and extensions.
What are those?
They're pre-built components for specific functions.
Like facial recognition.
Exactly.
So it's like plug and play FRS.
Yeah, kind of like that.
It's pretty cool.
And to keep things up to date,
Uh-huh.
it even has an OTA model update feature.
What does that do?
It lets you update the FRS models without having to shut down the whole system.
Oh, that's handy.
It is.
Wow, this SDK sounds like it has everything.
It's pretty comprehensive.
Anything else?
Well, you also get Helm charts and pre-trained models to make things easier. And, of course, it works with all sorts of NVIDIA tech,
Like what?
like CUA, XRiver Max, I/O, TensorT, all that good stuff.
So it's part of a whole ecosystem.
Exactly.
And it works with all kinds of different hardware.
It does. You can use it on servers in the cloud, even on little Jetson devices.
So lots of flexibility there.
Yeah, lots of options.
This is really impressive stuff.
It is.
Now, before we move on from DeepStream,
Okay.
I want to talk about another key player,
Okay, who's that?
the Triton Inference Server.
Ah, yes, that's an important one.
The documents say it's for high-performance deep learning inference.
It is.
So what does that actually mean?
Well, it means it helps you use your trained FRS models
Okay.
in the most efficient way possible.
So it's like the conductor of the FRS orchestra,
That's a great way to put it.
making sure everything is working together smoothly.
Exactly.
And it's fast too, right?
Oh, yeah, it can handle a ton of data really quickly.
Perfect for real-time applications.
It is.
What else is good about it?
Well, it can easily scale up. So if you need more power, you can just add more resources.
Nice.
And it's really easy for developers to use.
Even better.
Plus, it has this cool feature called Model Orchestration with Management Service.
What does that do?
It helps you manage multiple FRS models at the same time.
Oh, so you can have a whole team of models working together.
Yeah, like a super-powered facial recognition team.
Now, how does all this come together in a real FRS system?
Well, the documents mention a basic FRS architecture using DeepStream.
Right. I saw that.
And they even mention a custom probe flow, which sounds interesting.
Yeah,
You don't have all the details yet.
Okay.
But it sounds like a way to customize the system even more.
Interesting.
Yeah, we'll have to dive into that a bit later.
Definitely.
There's still so much to uncover.
I know, right?
But for now, I think it's time for a quick break.
Yeah, we've covered a lot of ground already.
We have.
We'll be back soon to explore the rest of this fascinating world.
Can't wait.
Stay tuned, folks.
All right, so we're back.
Back for more FRS fun.
That's right. We talked about the problems and some of the tools, but now let's actually see how these systems are built.
Okay, let's do it.
The documents you sent over talk about a basic FRS architecture using DeepStream.
Yeah, that one really caught my eye.
It's like a blueprint
Oh, cool.
for putting all these pieces together.
So how does it work?
Well, imagine a pipeline.
Okay.
The data flows through it step by step.
Like an assembly line.
Exactly. So first, you have your video stream.
Coming from a camera or something.
Right. And DeepStream takes that raw video data and pre-processes it.
Pre-processes.
Yeah, it gets it ready for analysis.
Like what kind of things?
Decoding the video, scaling the images, maybe cleaning up some noise.
So it's like getting the ingredients ready before you start cooking.
That's a good analogy.
Okay.
So once the video is prepped,
Okay.
it moves to the next stage.
Which is inference.
Inference.
That's where the magic
The
happens.
facial recognition part.
So DeepStream feeds those processed video frames to the model.
Right.
And then what?
The model analyzes each frame.
Looking for faces.
Yeah, it's trying to find a match.
In that database of known faces.
Exactly. And if it finds a match,
Mhm.
it can trigger certain actions,
Like what?
like unlocking a door
Okay.
or maybe sending an alert.
If it sees someone who shouldn't be there,
Right.
that's pretty cool.
It is, but it's not just about matching faces.
Oh.
DeepStream can do other things too.
Like what?
It can detect objects track movement, even recognize specific actions.
So it's like having a super security guard,
Exactly.
always watching
Yeah.
and analyzing everything.
It's really amazing what it can do.
So DeepStream brings all these features together.
Yeah, it makes it all work seamlessly.
Very cool.
Now, there was also something about a custom probe flow.
Right.
I remember that.
We don't know exactly what it does,
Okay.
but it sounds like a way to add your own custom logic.
Interesting.
Yeah, it's all about flexibility. Now I'm really curious about how we actually train these FRS model.
Well, the documents have a whole section on that.
Awesome.
They even provide step-by-step instructions.
You're better.
It's like a recipe for facial recognition.
I like it.
So first, you need to set up your environment.
Okay.
It's like getting your kitchen ready before you start baking.
Makes sense.
You need to create a special directory for your project.
Got it. A place to store all the ingredients.
Right. They call it FRS demo.
Okay.
And then you'll be using a tool called Unroot.
En route.
It's kind of like Docker for managing containerized environments.
Containerized environment.
Basically, it's a way to create a safe space
Uh-huh.
where you can install and run your software without messing up your main system.
Oh, so it's like a virtual sandbox.
Exactly.
Very cool.
So you'll import a specific Docker image.
Using a command they provide.
Yeah. It's already configured for training FRS models.
Nice. So we don't have to start from scratch.
Right. And then you can use another command.
En route list.
Yeah, to see all the environments you have available.
Got it.
Now for the actual training.
This is where it gets real.
You need to download and unzip some files first.
Like gathering all the ingredients.
And then you create a shell script.
A shell script.
It's basically a set of instructions for the computer.
Right.
Call it job.
Right.
Yeah.
And what goes in this script?
Well, you specify things like how many GPUs to use. And then the most important part is running the training script.
Python 3 train.py.
Exactly.
And then we just run the script and let it do its thing.
Well, you execute it with a
It's
command.
batch job.
Yeah. Yes. Yeah, and then you can monitor the progress.
Make sure it's not burning.
Exactly.
The documents also mention some references for more information,
They do.
like the face.evolve GitHub repository.
And the Docker Hub repository for that image we downloaded.
So if we want to dig deeper.
Exactly.
Okay, so we've set up the environment,
Right.
got our script ready.
And now the model is training.
But how do we actually see it in action?
Well, that's where the DeepStream demo comes in.
Oh yeah, tell me about that.
They have step-by-step instructions for running it.
Awesome.
First, you need to make sure you have a few things installed.
Like what?
CUDA 11 Plus with the NVIDIA driver and Docker.
Those are essential, right?
They are. Then you pull the Docker image for the demo.
Okay.
And you run it with specific configurations.
Like setting the oven temperature and bake time?
Yeah, exactly.
So then the containers run.
Right, and you can attach to it with a code editor.
VS Code.
Yeah, something like that.
Okay.
And then you navigate to the right folder.
Got it. So we're in the virtual kitchen now.
We are.
And how do we test the model?
Well, they explain how to add a reference person.
A reference person.
Yeah, someone you want the system to recognize.
Okay.
So you record a short video of that person, you put it in the right folder, and then you modify a configuration file.
A configuration file.
Yeah, it's basically a text file with some settings. You update the stream name, set the person's name, and enable reference adding.
So we're telling the system, hey, this is the person you need to learn.
Exactly.
And then what?
Then you run the pipeline script.
And the system analyzes the video.
Yeah, and tries to match the face to the reference.
Cool.
And you can even test it with multiple people.
Really?
Yeah, just record a video with multiple people,
Okay.
put it in the right folder,
Huh?
and update the configuration file again.
But this time we disable reference adding,
Right. This time the system is just trying to identify everyone in the video.
like a real-world scenario.
Exactly.
So what happens after we run the pipeline?
Well, the output video will be saved.
Okay.
It'll show all the faces that were recognized.
With their names?
Yeah, or NR if they weren't recognized.
Oh, that's interesting.
It is.
This demo sounds really cool.
It is. It's a great way to see how all this stuff works in practice.
And we built it ourselves.
We did. Well, kinda.
From a very detailed recipe.
That's a good way to put it.
Well, I think we've earned another break.
I agree. We've covered a lot today.
But there's still more to explore.
Oh, yeah. We've only just scratched the surface.
So stay tuned for part 3.
Where we'll go even deeper.
We'll see you soon. All right, we're back for the final part of our deep dive into facial recognition.
And we're going even deeper this time.
That's right. We're going to be looking at the heart of these FRS models.
The neural networks themselves.
Those names you mentioned earlier, ResNet, SE, ResNet Inception ResNet.
Yeah, those are the building blocks.
They sounded pretty complex.
They can be, but they're also really fascinating.
So how do they actually work?
Well, each one is a type of neural network architecture.
Architecture, like blueprints.
Exactly. It's the basic structure of the model.
Okay. And different architectures have different strengths.
Right, just like different buildings are good for different things.
Makes sense. So what's so special about ResNet?
Well, ResNet stands for residual network,
Okay.
and it was a big deal when it came out.
Why is that?
It solved a problem called the vanishing gradient problem.
Oh, that sounds bad.
It made it hard to train really deep networks.
Like the information got lost along the way.
Yeah, kind of like a game of telephone.
The message gets all jumbled up.
Exactly. But ResNet fixed that.
How?
It uses something called skip connections.
Skip a connection.
They're like shortcuts in the network.
Oh, so the information can bypass certain layers?
Exactly. It keeps the signal strong.
So no more lost messages.
Right.
What about SE-ResNet?
That one builds on ResNet.
Okay.
It adds channel-wise attention.
Channel-wise attention.
It's like when you look at a face,
Uh-huh.
you don't pay attention to every single detail.
Right. I focus on the eyes, nose, mouth.
Exactly, and that's what SE-ResNet does.
Learns to focus on the important features.
Right, it gives more weight to certain channels in the network.
So it's like a spotlight highlighting the key information.
That's a great way to put it.
And then there's Inception ResNet.
That one combines the best of both worlds.
So it uses Inception networks and ResNet.
Exactly.
Remind me what's special about Inception networks again.
They're good at capturing features at different scales.
Like looking at a face from up close and far away.
Exactly. It gives you a more complete picture.
And combining that with ResNet makes it super powerful.
It does.
So all of these architectures are working together in that IRAC-50 model.
That's right.
It's like a dream team of facial recognition experts
Each with its own specialty.
working together to solve the puzzle.
Exactly.
This is really amazing stuff.
It is. There's so much innovation happening in this field.
Speaking of innovation,
Yeah.
what about this move towards edge computing in FRS?
Oh, that's a really interesting development.
Can you explain what that is?
Sure. So traditionally, facial recognition was done on big servers.
In the cloud.
Right. But with edge computing,
Mhm.
we're starting to see those computations happen on the devices themselves.
Like on cameras and phones.
Exactly.
So why is that a good thing?
Well, for one, it's faster.
Because the data doesn't have to travel as far.
Right. It reduces latency.
Okay.
It also improves privacy
How so?
because the sensitive data stays on the device,
Oh, I see. That makes sense.
and it reduces bandwidth requirements.
Which is good for areas with limited internet.
Exactly.
So edge computing is making FRS more efficient.
yeah, and more versatile.
It's really changing the game.
It is.
It's amazing to see how far this technology has come.
It is, but it's important to remember that it's still evolving.
And that we have a role to play in shaping its future.
Absolutely. We need to be informed and engaged.
So what can we do as individuals?
Well, first we need to educate ourselves.
Learn about the technology and its implications.
Right. And we need to demand transparency and accountability.
From the companies using FRS.
Exactly. We need to make sure it's used responsibly.
So it's not just about the technology itself.
It's about the values and principles that guide it.
Well said. It's been an incredible journey exploring the world of facial recognition with you.
It has been fascinating.
We've learned so much about how it works.
And about the challenges and opportunities it presents.
We've talked about everything from the neural networks to edge computing.
And the importance of ethical considerations.
It's clear that facial recognition is a powerful technology,
It is.
and it's only going to become more prevalent in our lives,
That's why it's so important to have these conversations.
so it can shape its future in a positive way.
Exactly.
Well, on that note, I think it's time to wrap up this deep dive.
I agree.
We've covered a lot of ground,
We have.
but we've only just scratched the surface.
There's always more to learn.
And we encourage everyone listening to continue exploring this fascinating world.
Absolutely.
Check out the show notes for links to the documents we discussed.
And other resources to help you dive deeper.
And as always, we want to hear from you.
What are your thoughts on facial recognition?
What excites you? What concerns you?
Join the conversation on social media using the hashtag #DeepDiveFRS.
Let's keep this important dialogue going.
Together we can shape the future of this technology.
Thank you for joining us on this deep dive.
It's been a pleasure.
Until next time, keep exploring, keep questioning, and keep diving deep.